Have you ever wondered how we managed to shoot for the stars, quite literally? From the earliest of civilizations, humans have looked up at the night sky with wonder and curiosity. The vast expanse of the universe has always been a source of fascination, beckoning us with its mysterious allure. In the midst of this cosmic curiosity, a man named Robert H. Goddard emerged. A man who would come to be known as one of the pioneers of rocket technology. Born in the late 19th century, Goddard was a physicist and engineer with a dream that seemed impossible at the time. He wanted to build a device capable of reaching the stars, a rocket. His dream was met with skepticism and disbelief. Rockets were the stuff of science fiction, not science fact. But Goddard was not deterred. He was convinced that the exploration of space was not only possible but necessary. And so, he set to work. In the year of 1926, Goddard made history. He successfully launched the world's first liquid-fueled rocket. It was a modest contraption rising just 41 feet into the air. But its significance was monumental. For the first time, mankind had a tool capable of reaching the heavens. The launch marked a pivotal moment in human history. It was a proclamation of our species' indomitable spirit, our relentless pursuit of knowledge, our insatiable curiosity. It was a testament to Goddard's unwavering belief in the potential of rocket technology, his unshakable faith in human ingenuity. Goddard's success laid the foundation for all future space exploration. His work inspired generations of scientists and engineers, paving the way for the likes of Wernher von Braun, Sergei Korolev, and eventually, Elon Musk. The world watched in awe as the small, liquid-fueled rocket ascended into the sky, marking the beginning of a new era. An era where the stars were no longer just distant points of light, but potential destinations. An era where the impossible became possible. And so, the era of rocket science was born, thanks to the tireless efforts of Robert H. Goddard. But how did we go from a small, liquid-fueled rocket to landing a man on the moon? The answer takes us back to a period of intense competition, the space race, which pitted the United States against the Soviet Union. This was more than just a contest of who could get to the moon first. It was a battle of ideologies, a demonstration of technological prowess, and a testament to human courage and determination. Rocket technology was the linchpin of this competition. The United States and the Soviet Union poured vast resources into developing more powerful, more reliable rockets. These would not only carry astronauts into space, but also serve as potent symbols of each nation's technological and ideological superiority. The first major milestone came from the Soviet Union. On October 4, 1957, they launched Sputnik, the world's first artificial satellite. This small, beeping sphere, no bigger than a beach ball, was hurled into orbit by a two-stage rocket, the R-7. This marked the dawn of the space age and sent shockwaves around the world. The success of Sputnik represented a leap forward in rocket technology and sparked a sense of urgency in the United States. In response, the United States accelerated its own space program. Under the banner of NASA, the United States launched a series of increasingly ambitious missions, culminating in the historic Apollo missions. It was the Saturn V rocket, standing taller than the Statue of Liberty, which propelled the Apollo astronauts to the moon. This rocket was a marvel of engineering, capable of producing 7.5 million pounds of thrust, enough to lift a 50-story skyscraper. The space race was a period of rapid innovation and progress. It pushed the boundaries of what was possible and expanded our understanding of the universe. It was a time when the impossible became possible, when dreams of space exploration became a reality. The space race brought about numerous advancements in rocket technology, catapulting us further into the cosmos. The legacy of this era continues to influence and inspire current and future generations of space explorers. So, we've landed a man on the moon. What's next? Well, the next significant milestone in our epic journey through the skies was the shuttle era. The shuttle era was a revolutionary period in space exploration, which saw the development and launch of the iconic space shuttles. These reusable spacecraft were designed like no other before them. They took off like a rocket, could orbit Earth like a spacecraft, and land like an airplane. This versatility made them the workhorse of America's space program for over 3 decades, from the early 1980s right up until 2011. The primary goal of the shuttle era was to make space travel more frequent and cost-effective. The space shuttles were designed to be reused up to 100 times, significantly reducing the cost of space travel. They were instrumental in numerous space missions, from launching satellites and conducting scientific experiments to repairing the Hubble Space Telescope. However, one of the most notable achievements of the shuttle era was the construction of the International Space Station, or ISS, a symbol of global cooperation in space. The ISS, a habitable artificial satellite in low Earth orbit, serves as a home where crews of astronauts live and work. The space shuttles carried up large modules and other components to build the ISS, piece by piece, making it the most significant structure ever assembled in space. But, like all good things, the shuttle era had to come to an end. These space shuttles were retired in 2011 after 135 missions. The retirement of the shuttle program marked the end of an era, but also the beginning of a new one. It paved the way for the next generation of spacecraft and opened up new opportunities for commercial space travel. The space shuttles served us well, but all good things must come to an end. As we bid farewell to the shuttle era, we look forward to the exciting prospects that the future holds in our quest to conquer the skies. With the retirement of the space shuttle program, who would take up the mantle of space exploration? That's the question that was on everyone's mind. Enter private companies, breaking the monopoly of government-run space agencies. Two names that stand out are SpaceX and Blue Origin, both established in the early 2000s, and both with a common goal: to make space more accessible. Let's start with SpaceX, a company founded by tech entrepreneur Elon Musk. Musk, with his audacious vision and relentless pursuit, has been a game-changer in the world of space technology. SpaceX's crowning achievement has been the development of reusable rockets. Yes, you heard that right, reusable rockets. Rockets that can be launched, returned to Earth, and then launched again. This is a significant leap from the traditional single-use rockets which, after serving their purpose, would fall back to Earth, never to be used again. Through this innovation, SpaceX has not only made space travel more cost-effective, but also more sustainable. On the other side, we have Blue Origin, founded by Amazon's Jeff Bezos. Blue Origin has been more methodical, focusing on building a strong foundation for future space travel. Their New Shepard suborbital vehicle, named after the first American in space, Alan Shepard, is designed to take tourists to the edge of space, providing them with a few minutes of weightlessness and a view that's out of this world. Both companies have also made strides in commercial space flights. SpaceX's Crew Dragon spacecraft has already ferried astronauts to the International Space Station, while Blue Origin's New Shepard is ready to take paying customers on suborbital joyrides. The entry of these private companies into the space race has sparked a new era of innovation and competition. The sky is no longer the limit. It's just the beginning. Private companies have certainly changed the game, making space more accessible than ever. And as we look to the stars, it's clear that the future of space exploration is brighter than ever before. But where do we stand today in terms of rocket technology? Rocket technology in the present day has evolved leaps and bounds from its humble beginnings. We've moved from the rudimentary, liquid-fueled designs of Robert H. Goddard to sophisticated, reusable spacecraft that can land back on Earth after delivering their payloads to space. Today we're reaching for planets beyond our own. Mars has become a prime target for exploration. Scientists and space enthusiasts around the globe are excited about the prospect of not just landing on the red planet, but also establishing a human colony there. NASA's Mars rover missions, like Perseverance, have been paving the way for this ambitious goal by studying the Martian surface, atmosphere, and potential for life. Private companies like SpaceX are also contributing to the exploration of Mars. The company's Starship, a fully reusable spacecraft currently under development, is at the heart of Elon Musk's plan to make human life multiplanetary. The Starship is designed to carry up to 100 passengers, and Musk envisions a future where thousands of these spacecraft will ferry humans to Mars to establish a self-sustaining colony. We're also revisiting our closest celestial neighbor, the Moon. Both governmental and private entities are planning lunar missions in the near future. NASA's Artemis program aims to return humans to the Moon by 2024, and this time, they plan to stay. Lunar colonies are in the works, with the goal of using the Moon as a base for further space exploration. Rocket technology is not just about reaching for the stars, though. It's also about making space more accessible for everyone. Companies like Blue Origin and Virgin Galactic are working on suborbital space tourism, aiming to give ordinary people the chance to experience the awe-inspiring view of Earth from space. We've come a long way since Goddard's first rocket, but there's still so much more to explore. In the realm of space exploration, we're just getting started. The current state of rocket technology is only a stepping stone to the incredible journeys that await us in the cosmos. So what does the future hold for rocket technology? The exciting thing about the future is that it's full of unknowns and possibilities. The same goes for the future of rocket technology. If we take a moment to listen to the experts, we can get a glimpse of what might be on the horizon. Many experts believe that the future of rocket technology will be defined by two main trends: interstellar travel and space tourism. Now let's unpack these a little. Interstellar travel is not just the stuff of science fiction anymore. The development of advanced propulsion systems, like the concept of nuclear propulsion, could make it possible for humans to venture beyond our solar system. Imagine a future where we could potentially visit distant galaxies and explore other planetary systems. It might sound like a far-fetched dream, but remember, so was landing a man on the moon once upon a time. On the other hand, space tourism is already making headlines. Private companies are working tirelessly to make space travel accessible to the average person. The idea of hopping on a rocket for a weekend getaway to the moon might not be as far away as we think. Companies like SpaceX are developing reusable rockets, which could significantly bring down the cost of space travel, making it a viable option for tourism. But let's not forget about the potential for advancements in satellite technology and the exploration of Mars. Who knows, we might soon be watching live broadcasts from Mars, or maybe even setting up permanent human colonies there. While these possibilities are thrilling, they also come with their own set of challenges. There are technical hurdles to overcome, not to mention the ethical and environmental considerations of such ambitious endeavors. But as history has shown us, when it comes to rocket technology, the sky is not the limit, it's just the beginning. While we can't predict the future, one thing is for sure: rocket technology will continue to push the boundaries of what's possible. From Goddard's first rocket to SpaceX's Starship, we've made incredible strides in rocket technology. We've traveled from the dawn of rocket science, where Robert H. Goddard's rudimentary yet revolutionary rocket design marked the beginning of a new era, to the intense competition of the space race, a testament to human tenacity and the power of innovation. We've witnessed the shuttle era, where routine space travel became a reality, and the rise of private companies like SpaceX, altering the course of space exploration. Today, rocket technology is not just about reaching the stars, but also about improving life on Earth, from satellite communication to climate studies. This journey, fueled by the indomitable spirit of mankind and the relentless pursuit of knowledge, has transformed our civilization and our perspective of the universe. As we continue to reach for the stars, who knows what the future of rocket technology will bring?